Hey y'all, my name's Brandon. This is video assignment number 2. We're talking about specific compounds that are pharmaceutical uses and things of that nature. We're talking about their structural setup, the functional groups within each compound, and the IR spectrum assignments and their frequencies. My compound was fenofibrate. It is an anti-cholesterol medication used to treat hypercholesteremia and hypertriglyceridemia. As you can see, it's very pretty with a bunch of lines, a bunch of little different letters and numbers and zigzags and doohickeys that I'm going to go in and explain. So this is fenofibrate, and this is its molecular setup. Okay, so right here we see two structures that are aromatic rings. They both can correspond with resonance as well. Off of here we see that there's a lone chloride, and that's a known functional group of an alkyl halide. Up here with this double bonded oxygen connected to a carbon and two other R groups, we can define that as a ketone. Right here with this single bonded oxygen to two R groups, and they are both carbons, we can define that as an ether. These are two lone carbons up here, both with hydrogens attached to those C to H hydrogen or C to H bonds, those single bonds, those are alkanes. These C to C double bonds, those carbon to carbon double bonds, those are considered alkenes with an E, and that's just because of the number of pi bonds that are located in that structure. Over here, it's starting to get harder to see because it's smaller. The board is small, but it is a carbon attached to a double bonded oxygen, but it is also attached to a hydroxide group, which is an oxygen and a hydrogen. That's considered a carboxylic acid. So basically that is the breakdown of the functional groups of my compound. I'm pretty sure. Yeah, cool. That's the breakdown. So now, something new that we've learned in class is IR spectroscopy and frequency assignments with each of these functional groups. So I'm going to kind of explain what IR spectroscopy is. The frequency is the number of waves within a certain time frame in infrared spectroscopy. So each of these different things, based on their bonds and based on what they're connected to, have a higher frequency between one another. So alkanes and alkenes, like I mentioned before, alkanes are the C to H's and alkenes are the C to C double bonds. They have, the C to H bonds have a frequency of 2850 to 3000. The C to C double bonds have a frequency of 1620 to 1680. Our alkyl halide group, which is this carbon connected to this lone X factor, whether it's chlorine, bromine, fluorine, that has a frequency of 600 to 800 waves per second, or waves per interval. This ketone right up here with the double bonded oxygen to it, the C to double bond stretch has a frequency of 1705 to 1725 waves per interval. Once again, this aromatic ring is exactly identical to this one, so it'll have the same sort of frequencies going on within the ring with the carbon-to-carbon double bonds, the carbon-to-hydrogen bonds. The only difference is that it's connected to an ether and a ketone rather than a ketone and an alkyl halide. So the ether, the oxygen, connected by two single bonds to two R groups. In this case, they're both carbons. That ether, right on the O, those stretches, have frequencies of 1000 to 1300. Up here in these little carbon to hydrogen bonds, picture this carbon having three hydrogens branched off of that and three hydrogens branched off of that. Once again, those are alkanes. They have the same frequency as the alkanes in this aromatic ring. The carboxylic acid group, we're actually dealing with two different bonds. We're dealing one with the double bonded oxygen and one with the actual hydroxide group to it. So the bond with the double bonded oxygen, right here is pretty similar to the one up here in the ketone. It's 1700 to 1725. This one was 1705 to 1725. And then this hydroxide group will have, it's the strongest out of all the bonds in this structure, and mainly that's because of hydrogen bonding between the O and the H. And that bond setup is has a frequency between 25 and 3,300 waves per annum. So that's the breakdown of the structure. Like I said, this is the skeletal structure of fenofibrate. Fenofibrate is used for cholesterol in patients with high risk of heart disease. It reduces LDL, VDL, LVDL, and triglycerides, and it also likes to increase the HDL. Other than that, I hope I've answered all questions for you guys. If you have any questions, post in comments below. I will try and answer them as best I can. I'm not a chemist by any means, but I'll do my best. Like I said, we broke down the structural groups, and we broke down a little bit of IR spectroscopy for you guys. All right, take it easy.